This is our second day analyzing polynomial functions, and let's jump right in with this problem right here. I apologize if you can't see from where you're sitting. Number one, it says, is this an odd degree function or is it an even degree function? What do you guys say? Even, definitely even. Now, if you were to explain that to somebody that hasn't been to class yet, what would you say? Why is it even? Because both arrows are facing the same way down, right? So how many arrows are facing down? Two of them. The number two is even. That's an easy way of knowing whether the degree of your function is odd or even. If you'd have one arrow up here, end behavior, one arrow down here, then that would be an odd degree function. Both of them down here, even degree function. Both of them up here, even degree function. So for sure, the answer here, it's an even degree function. Now, what's the most basic even degree function that we're used to, that we're comfortable with? Y equals what? X to the second, right? That gives us a parabola, right? So y equals x to the second gives us a parabola. We know that a parabola, y equals x to the second, would open up, and that leading coefficient would be positive. If it's positive, it opens up. If your leading coefficient is negative, it would open down. So right here, when it says the leading coefficient of this polynomial function must be positive or negative? Negative, because it's opening, it's going down. The end behavior is going down. So the answer is negative. Okay. The next part is asking us to fill in the blank, and we need to understand what this means as x approaches negative infinity. Okay. If you're totally lost or totally confused, x are your x values, your x number line. Your x axis goes left and right. So it says as x goes to the negative infinity, that's saying as you go to the left. It can't be that way, that's positive infinity. As you go to the left, where are your y values at? Where are they going? Are they going up forever or are they going down forever? Down forever. So as my x values are going to the left, my y values are going down. So what do I write right here? Negative infinity. That's exactly right. And as x approaches positive infinity, here are your x's, positive infinity is this way. Your y values, are they going up or are they going down? They're going down forever. The y values are going down. So as you go x approaching positive infinity, your f of x values are approaching negative infinity. Does that make sense? So we're going to type in a negative infinity right there. It's pretty much this simple. You got to understand that x arrow negative infinity, that means left. X arrow positive infinity, that means right. F of x is your y values. Negative infinity, that means down. F of x positive infinity would mean up. Now, we don't have f of x going to positive infinity, but that's how you're supposed to think about end behavior with its appropriate notation. All right, number 4, how many real zeros does this polynomial have? What we need to know is the definition of real zeros. What does real zeros actually mean? X-intercepts, where it's crossing the x-axis, right? So how many does it have?
2.
1, 2. So for sure, your answer is there are 2 real zeros. Okay. Next question is about those real zeros. Which of the following could be real zeros of the graph? Circle all that apply. Could it be 0.5?
Yeah.
Right here? There's an x-intercept? No? Okay. 2.5? Nope. All right. Yeah, negative 0.5 for sure. That one's good. So let's circle that one. And what about that last one, negative 4.5?
Yeah.
1, 2, 3, 4.5 right here? No. So that one's not it either. Technically, your x-intercepts, your solutions, your real zeros are negative 0.5 and also negative 3.5 or 3.6, negative 3.6, right? But that obviously is not there. This is incorrect. So this is the only one that works out of those possible answers. Number 6, state the max value coordinate, not the relative max. So the question is, which one is the max value? This blue dot up here or the blue dot down here? Which one is the max?
The up top one.
The up top one.
Relative is the small
Relative is the small one, right? It is a max value relative to this curve, right? Goes up, reaches a max height, then it goes down. It's a relative max. It's a max value relative just to this curve. Anyway, so yes, state the max value coordinate, not the relative max value coordinate. What is this coordinate up here? Coordinate negative 2, 4, right? There we go. Which of the following could be the x value of the relative max value? So here's a relative max. What's the x coordinate?
2.5.
Yep, 2.5 sounds good. 2.4 sounds good. So let's circle that one, 2.5. Number 8, state the relative minimum value. Write the answer here as a coordinate. What is the relative minimum value? So the relative minimum value is down here, and that location is 1, -5. 1, -5. That's your relative minimum. It's not the absolute minimum because it does go further down. It's just the lowest point relative to this curve right here. Okay. This polynomial function must have the degree at least of what? 4. And how do we know that?
It changes directions.
The directions that it's going, right? So it's going up, that's 1. It's going down, that's 2. It's going up, that's 3. It's going down, that's 4. So the directions, the number of directions that the graph actually travels, that'll be the least degree possible. So this polynomial function must at least be the degree of 4, okay? Could it be 6? Yes. Could it be 8? Yes. Could it be 9? Can't be 9. Why not? Because 9 is an odd degree function, and we know odd degree functions don't have an even amount of arrows going down. It would be up here and down here, or up here and down here. So we say that it's at least 4. It's even. That means it could be 4, it could be 6, it could be 8. It can't be 7 because that would be an odd degree function, and obviously this is not an odd degree function. How about the domain? What's the domain? X equals all real numbers. How about the range? Oh, actually, before answering that, why is it x equals all real numbers? Because it does go to the left and to the right forever, right? It goes to the left and to the right forever. Domain are your x values. It goes to the left, to the right forever. So x equals all real numbers. The range are your y values. Does it go up forever and down forever? No, it doesn't. Right? If it did have an arrow up here and an arrow down here, then yeah, you would say y equals all real numbers, but it doesn't. So how do we describe the range? Y is what? Y is less than or equal to 4, the maximum value 4. Thank you so much. That is a correct answer. And this is about it. All the stuff that's going to come out on the quiz this Thursday is going to have these types of questions, but there are a couple more I want to review with you right now. Check this out. We have a graph and we have 6 different functions. And let's see which one it could be. So one option, if I did give you this question on the quiz Thursday, you could actually get Desmos out and type in every single function and see which one gives you this graph. But that would take a long time. There's a lot of things that we already know that we could instantly eliminate several of these options, right? So, for example, we could look at this guy and say, well, I know that this has an end behavior down here and up here, has an odd amount of arrows pointing up, odd amount of arrows pointing down, so it has to be an odd degree function. It cannot be an even degree function. So it cannot be this guy, so you could eliminate that guy right off the bat because of that even degree function, right? The rest of them are odd degree functions. Now, if we think about an odd degree function, the easiest type of odd degree function would be y equals, let's say, x to the 1. That would be a diagonal line going through the coordinates 1, 1, 2, 2, 3, 3, 4, 4, and also a -1, -1, -2, -2. It'd be a diagonal line, right? Which means that that end behavior ends up in quadrant 1 and quadrant 3. And if we analyze this, the leading coefficient of this basic line, that's an odd degree function, is a leading coefficient of a positive 1 in this case. So if you do have a positive leading coefficient, you should have end behavior down here and up here. So this guy does have the end behavior in quadrant 3 and quadrant 1. So that must mean that the leading coefficient is positive, which means we could eliminate this guy because that one's negative. Does that make sense? Because of that negative, you could eliminate option B. Okay. What else? You know what? Let me erase this. Oh no, I can't erase it. Well, ignore that red line. Sorry about that. Let's focus in on the actual graph, but ignore this red line. But and yes, absolutely. Great question, great statement, and great truth that you just said. The C value, the constant value at the very end, is your y-intercept value. We learned this back with parabolas. If we wanted to find the y-intercept, all you have to do is set x equal to 0 and solve. So if you did put zeros in here and solved it, it would end up being the C value, the constant value, right? So this guy right here is saying that it has to cross through the y value of 1. And obviously it crosses through 2, not 1. So it has to have the constant value of 2. It cannot have the constant value of 1. So we could eliminate all the ones that have a plus 1 at the very end. So that would be eliminating A, eliminating D. So we're down to those last two options, E or F. Okay, so how could we determine which of those two are correct? Well, one option is to just graph both of them on Desmos, or another option is to understand that a graph really represents all the x and y values that work for an equation. So you could technically pick this point right here, which is the coordinate -1, -3. And this coordinate is really saying that if you plug in -1 in place of the x values, plug in a -1 on both of these x's, do the math, your answer should come out as a -3. Okay, so that's another way of doing it. So if we did try that, this is what it would look like. Let's first begin by working on option F, replacing these x's with parentheses, and now let's actually plug in the input, the x value of -1, right in there, -1, -1. And now let's do the math. -1 times itself 3 times, that's going to give you a -1. And then, of course, multiply it by 2, and that will give you -2. And then we continue on over here, -3 times -1, that's +3. So we really have a -2 plus 3. Whoops, sorry about that. And then we bring down that +2. So -2 plus 3 plus 2, that is 3 as a final answer. So what does this mean? That the input -1 on option F should give us the output 3. And we know that the coordinate -1, 3 is not part of this graph. So this answer doesn't work. In other words, it's not -1, -3. When you plug in a -1, you're supposed to get out a -3, and this did not happen on option F, which means it's incorrect. Okay, so obviously the answer is option E. Okay, so if you were to graph this on Desmos, you should see this perfect exact graph right there on Desmos. Or we could also verify it by simply plugging in the -1 right there and right there. I might as well demonstrate that. So I am plugging into option E right here. I replaced the x's with parentheses, and I am plugging in the -1. And we should see that when we do this math, the answer comes out, the output ends up being a -3. So working on the -1 times -1 times -1, that is -1. Multiply that by 2, you'll get a -2. And then over here, you have to do the exponents before multiplying by -3. So -1 squared is +1. So you really have a -3 times a +1, that is -3. And of course, we bring down that +2. And when we combine -2 minus 3, that's -5. -5 plus 2, that ends up giving us the output -3 that we actually see right there. So option E works. Of course, if you're like, man, I don't want to do all this work and I don't want to do all that work to determine which one's which, you could always plug them into Desmos and see which one's a correct graph with Desmos. So which ones could we eliminate right off the bat with this one?
The ones that have the 2.
The ones that have the 2 as the constant, right? Because if you have a 2 as a constant and a 2 as a constant, that must mean that your graph passes through the y-axis at 2, and obviously it doesn't pass at 2. So these guys could both be eliminated. So we know it doesn't pass at 2. We do know that it passes the y-axis at 1. So it could be A, B, C, all those pass at 1. Okay. What else could we do, or what else do we know that could eliminate some of these possible options? B and C could both be eliminated because B, the leading coefficient's negative, and we know that the leading coefficient of an odd degree function, if it's negative, it would flip it and it would be up here and down here. So B is not possible. And C, the degree is 4. That means that there's an even amount of arrows pointing up, and that's obviously not the case here. So that gets eliminated as well. So now we're down to either A or D. And which coordinate should I use to test? Give me a nice clean coordinate. Anybody? -2, -1. Okay. That I don't know. Is that a nice coordinate right there? Or is it down here? I don't really know. Yeah, that might work. You know what? Let's try it. Let's just see. -2, -1. So when I try it for option A, I'm going to rewrite the x's with parentheses, and I'm going to plug in a -2 right in there and see if it gives us the output of -1. So when I think -2 times itself 3 times, -2 times -2 is 4 times -2 is -8. Then I have -3 times -2, that's +6. And then +1 comes down. From left to right, -8 plus 6 is -2. -2 plus 1 equals -1. So the output's -1, and that is a true statement. I did plug in the -2, and it gave us the output -1. Now, just to double check, let's see if that happens over here on option D. When I plug in a -2 right there, I'll try to do this in my head. -2 times -2 times -2, that's -8. Plug in a -2 right there, that'll be a +4 times -3, it's -12. -8 and -12, that's a big negative number. +1, that's -13. Obviously, that's not the output, -13. So yeah, option A is the correct one, not D. What do you guys think? If you understand this stuff, you should be ready to ace the quiz on Thursday.